Okay, so for your homework, you were supposed to write a function that takes a string in as a parameter, reverses that string, building up a new string, returns that new string, and then should display the reverse string, right? Okay, how'd that go? Not bad? All right, so let's go ahead and create our function. Function is going to be to do something. We want the one that returns a value in the end. So we'll call this guy reverse string, and we're going to have this guy take a string as a parameter, so we'll call this input. All right, and then we're going to have to create another variable. Maybe we call this guy answer, and we'll start answer off as the empty string. Okay, now before we do anything else, in fact, let me just get rid of answer for a second, because I had a lot of people come and ask questions about this. Whenever you're solving your problems, you want to build it up in little tiny baby steps. Okay, if you try to conceive of the entire solution, even though this seems like it's not that difficult, if you don't want to be guessing, like, do I want to have a loop? Do I want to do this? Do I want to do that? You want to break it down into little tiny baby steps. So actually what we're going to do first here is we're going to display all the characters of input, whatever input is. Input is whoever called this function. So for example, if I come down here and I call reverse string and I pass it hello, that particular call to this function, input, will be equal to hello. If I call that same function again, and I pass it world, the second call to this function, input will be world. Okay? So no matter what I call my function with, the input will be stored inside of a variable called input. Okay? The whole purpose of a function is so that we can write something once and reuse it over and over and over again. All right, so we want to write some code that's going to go through and spit out this guy forwards. So just every single character of the string. Start with that. All right, so we're going to need a loop to pull that off. We're going to count from 1 to the length of our string. Okay, 1 to length of input, incrementing by 1 each time. And then we'll go ahead and we'll just print that out. And what are we going to print out? Well, let's start off by actually printing out I. See the indexes that are printing out. All right, so I'm going to print out our variable I. And I'll go ahead and take this second call out here. Now, right before we do that, I'm actually going to give ourselves another print. I'm going to put this print up here, and what we're going to actually print out is the length of input. All right, so right now, what does this function do? It's called reverse string, takes a single parameter input, which, for example, might be the string hello. The very first thing we're going to do is we're going to print out the length of that input. So in this case, the length should be 5. All right, then we're going to have a loop that goes through, has a variable name I, starts off at 1, goes all the way to the length of input, which we will see as 5, incrementing by 1. So we should see, and then we're going to print that value each time. So we should see a 1, 2, 3, 4, 5 display to the screen. Okay, go ahead and run this. Here's our length 5. There's our 1, 2, 3, 4, 5. All right, so we now have access to that index. This loop has nothing to do with our string input, other than the fact that the number of times it goes through is the same as the length of that string. I have to choose to use this variable to access elements of this guy. All right, so now instead of printing out I, we're going to print out elements of our string. So that's this guy here. We're going to print in our string input, print out the letter I. Okay, so this is going to go through. Again, it's going to print out the length of our string, which is going to be 5 in this example. Then it's going to go through from 1 to 5, and each time through it's going to print out the letter. So it should print out H-E-L-L-O. Run this again. There's my 5, H-E-L-L-O. So now I've accessed individual elements of this guy. Now, I'm not going to change my function at all. Instead, I'm just going to come down here. We'll change this guy to be elephant. Now this guy has 8 characters in it. Run the exact same code again. Notice the length is now 8. And again, it's got all the letters of elephant. Okay? So, that's step 1, is we need to be able to access individual elements of this. Now, we know that we actually need to walk through our string in reverse. So instead of going from 1 to the length of the string, we really want to go from the length of the string down to 1. Okay? So we're going to just swap these guys around here. So we'll go from starting at the length of our string down to 1, but changing by -1 each time. So we count backwards. Okay? So run this again. Still have a length of 8, but now it's going to be elephant in reverse. Okay, so we're accessing those characters in reverse. Well, what are we going to do with the characters? We need to build them up inside of another string. So instead of printing out the length up here, let's go ahead and give ourselves that variable. So we're going to have a new variable, and we'll call this guy answer. And we'll start answer off as the empty string. Okay, and inside the loop, rather than printing every character, what we want to do is we want to get that character. So we'll throw that down there. Don't get it too close to the garbage can. Okay, we want to take that character and we want to append it onto our answer to build up our answer. So our answer starts off as nothing, and then we'll append on a character, append on a character, append on a character, append on a character until we build it all the way up. Okay, so we do that inside of text. We're appending something onto answer. What are we appending? We're appending the current character from input. Okay? Then in the end, we'll return answer. So this guy creates a new variable called answer, sets it equal to nothing, loops through every element of input from the last element to the first element, stepping by -1. Each time through, it adds a character onto answer. Which character? The character at position I. Okay? After this loop is done, when all is said and done, at the very, very, very end, we return whatever the current value of answer is, which in our current example should be elephant in reverse. Okay, what's the output of this program going to be right now? Don't guess, look at the code. If you trace through this code, what should this display to the screen?
Nothing.
Nothing. Okay? Why does it return nothing? Or why does it display nothing?
It's not going to print for the function.
Yeah, I'm calling my function here, and sure enough, answer is going to come firing out of here, and I'm doing nothing with it. All right, so this guy runs, no harm, no foul, but doesn't actually do anything. So now I'm going to go and I'm going to print this guy out. And there's my elephant in reverse. Make sense? Okay, and I can call this guy now with any string. There's hello. Don't have to rewrite it. I can call the function multiple times. Here, we'll throw Christian worldview in there. So there's hello backwards, there's elephant backwards, and there's God. All right, so write the function once, call it multiple times. That's functions. Kind of make sense? All right, so always break it down into little tiny baby steps and only solve pieces of the problem. Eventually, you'll be able to just sit down and solve this problem in no time at all. And then the things that you'll have to solve in pieces are going to be larger problems. But for those of you who are struggling with this one, I watched you spend a lot of time guessing at, oh, well, so do I just create a variable? Do I just do this? Do I add an if statement? Just dragging stuff out there haphazardly without really any thought process going on behind it. Okay. So what we want to look at today is lists. All right, so we have a couple different ways of dealing with lists. For starters, let's do this. We're going to create a variable. We'll call this guy a list. And this variable is going to start off as the, well, actually let's do this. Let's create a list containing a few things. And we're going to have it just contain a couple of numbers. So we'll have it contain 1, 2, and 3. All right, and then what we want to do is we're going to go ahead and just print out our list. We want to know what it looks like to print out this new structure called a list. All right, so in JavaScript it shows our list as 1, 2, 3. So now what we have is we have a collection of information, 1, 2, and 3, stored under a single variable name. Now, let's kind of go back and connect the dots here a little bit. Okay, this is when we were starting to talk about arrays. Okay, so jump back here real quick. Right now we know about two things in Blockly, and really GameSalad too. So we know about, let's call this storage. We know about variables. That's storing a single value in a name, in a single variable name. All right. We also have the idea of strings, or Blockly just calls it text. Okay, but a string. Okay, a string is a collection of characters, specifically characters. So this is a collection of characters stored in a variable name. All right, so we do have the ability to hold collections of stuff up to this point with our strings, but the only kind of stuff we can store is characters. So with a list, or in some languages these are called arrays, we now have a collection of data stored in a, actually I'm going to update data. I'm going to say a collection of like data, and that's mostly a truth, and that actually becomes a difference between loosely typed and strongly typed languages. But a collection of like data stored within a single variable name. Okay, so this introduces this concept in other programming languages, well, in programming languages in general, known as an array, which is really this definition right here. Now, arrays are typically set up in an interesting way. When we build an array, so for instance, in this example right here, we've built a list, let's call it an array for right now, with 3 elements in it, 1, 2, and 3. What this is essentially doing for us is we're creating a structure that looks like that. Creating a structure that looks like that. And in this example, I named this guy a list. And this variable is said to point to the beginning of this list, beginning of this array. So in many languages, this guy is called a pointer. All right, a pointer is a primitive type variable capable of holding a memory address. Okay, that's what a pointer is. No different than an integer capable of holding an integer, no different than a string capable of holding a collection of characters. A pointer is capable of holding memory addresses. Okay? The problem is that memory addresses immediately become kind of intimidating for beginning programmers. As soon as we see a memory address, something that looks something like a crazy hexadecimal number, 1, 2, 3, A, B, C, 4, 5, and usually you might have a 0x before that, something like that. So something like that might be stored inside of a memory address, and human beings don't really like things like that. Looks a little foreign to us and we don't really know what to do with it. But it's called a pointer, and it's called a pointer for a good reason. Well, first of all, I've said because it points someplace else. But really what it's pointing to is we've described our array or our list looking like this. But in actuality, more is happening in memory than meets the eye. Similar to strings, arrays are indexed, bucket 1, 2, and 3. And actually, just for the sake of this example, let's do 30, 35, 51, 88. Just so they're not 1, 2, and 3 matching up to our other stuff. So 35, 51, 88. This is 35, 51, 88. Those are the values we are storing in our array. And assuming that lists work the same way as strings in Blockly, this is position 1, position 2, position 3. In most programming languages, arrays and strings are 0 indexed. So this would be 0, 1, 2 instead of 1, 2, 3. Okay, and we can probably see that in, we'll see it here in a few minutes when we look at the JavaScript version of it. It'll probably subtract 1 from whatever our base is, because JavaScript certainly indexes these guys starting at 0. All right, but in any case, just like we dealt with our strings, where we got a character at this position, and a character at this position, and a character at this position, lists are similarly indexed. Now, on top of that, these values actually live somewhere. They live somewhere in memory. And I'm going to start our memory address off at 100. And we're going to go to 104. And we're going to go to 108. Okay? Now, I'm doing that for a reason. So what we're doing here is we're going to say that the value of a list, and this gets back to our idea of storage, or a list is a collection of like data stored within a single variable. So the single variable in this case is this guy named a list. All right? And what I'm telling you is a list is actually just like any other variable. It holds a single value. The value it holds is a memory address which is said to point in memory to where the actual collection of values are. Okay? So this guy is a variable just like any other variable. It just happens to point into a place in memory. We happen to recognize that it's of type list, and therefore we have to deal with it a little bit differently. Okay? So, when I want to access this guy right here, I'm actually accessing whatever value lives at memory address 100, which is the base address of this guy. When I access this guy right here, I'm actually accessing whatever lives at memory address 104, which is one offset from the base address of this guy. And let me show you what that means. In most of our modern languages, since we're storing integers here, ints are 32-bit or 4 bytes. That's the size of an integer in most of our modern languages. Okay? Which means that if I want to access a list at position 1, this is actually equal to the value that lives at a list plus, in this case, 1 minus 1 times size of int. Put a different way, this is a list is actually 100. We're adding to that 1 minus 1 is 0 times size of int is 4 bytes. So that means that the first element lives at position 100. 100 plus 0 times 4 is 100. Okay? And that guy lives there in the that first bucket. If I want to access bucket 2, this will be a list plus 2 minus 1 times size of int, or 100 plus 1 times 4, or memory address 104. Similarly, a list at bucket 3 108. Okay? So arrays are actually stored in what's called contiguous memory. Contiguous memory. Right? So that means memory in a row. So when we go and create a list, it has to give us enough space to store however many things we're going to put in that list in a row. Okay? Now, we don't have to know how Blockly implements this. Okay? Well, let me ask you, let's reword that. How does I'm going to ask two questions. You decide which one you want to answer. How does Blockly implement lists? And do we have to know how Blockly implements lists? And it's kind of a trick question. Because what is Blockly? Is Blockly a programming language? What is it? Well, what's a programming language? Everybody should have this ingrained in their soul for studying from the midterm. What's a programming language? Programming language, a tool that attempts to mimic the way human beings solve problems. Okay? We solve problems one way, using memory, asking questions, and repetition. Programming languages give us the ability to do that. Does Blockly do that? Well, we'll look at Blockly here. Do I have the ability to create variables? Do I have the ability to ask questions? Do I have the ability to do repetition? Okay. Is Blockly a programming language? Still a trick question. Okay. Why not? What does Blockly not do for us? It certainly gives us a visual way of building things that potentially could do these things. But Blockly doesn't do any of this itself. What does Blockly do?
It uses programming language to solve the issues.
Yeah, it translates into other languages, right? So what I'm saying here is that this isn't a Blockly thing, this idea of lists and arrays. Okay? Blockly is calling them lists visually for us. But behind the scenes, it's getting created as something else. So if we go in here and we look at the JavaScript, this is an array of elements. If we look at the Python version of this, this is an array of elements. Okay? So I'm telling you, because I know these languages, that this is an array. even though Blockley's calling this a list. Okay? And arrays are implemented like this in most languages, including these. Okay? Now, let's go back in here to Blockley. So we created the list, we printed the list out. What other things can we do to lists? Well, we can certainly create an empty list. We can actually build a string. Well, we can create a list with so many things repeated. So let's build a couple of lists here. Just see some different ways we can create lists. So we can create a list with the text hello repeated 5 times. So this is just going to be a list with 5 elements in it. Hello all 5 times. Fair enough. We can create a list. Where's my delimiter one? Yeah, this is a fun one. We can create a list from some text. So for instance, I can put some text in here, and maybe I want to put 1, 2, 3, 4, 5. I've separated it by commas, and then the default delimiter is a comma, but if I wanted to put question marks in here, I would have just changed this to a question mark. And now it's going to build me a list from this text using this delimiter. So I should have a list with those 5 elements in it. 1, 2, 3, 4, 5. Similarly, I can get text from a list. So, for example, if I want to go and create my list here, do this. And we'll create this guy with some numbers just like we did before. 33, 55, 88. And we could add additional things. If we want to have more elements in our list, we can certainly add more elements in our list. So we'll add a 65 in here. All right, so now we have a list. And what I'll do is I'll go into lists, and I'm going to, my delimiter one, yeah, here, this guy. We're going to print, and we're going to make text from a list. What's the list? The list is our thing called a list. All right, so I'm saying I'm going to make text from a list, but I want to have it delimited by smiley faces. Okay, so what it's going to do is it's going to create me a string, 33 smiley face, 55 smiley face, 65 smiley face, 88. It's going to build that as a string for me, given this list as the source. I'm just going to print that out right now. Okay, so there's all my smiley faces. So it converts, we have the ability to convert a list into a string. We have the ability to create a string into a list. We have the ability to get the length of a list. So I can print however many characters are in this list. So in this case, well, however many elements are in this list. So in this case, we have 4. So there's 4, number of elements in that list. We can find the first occurrence of something in a list. So we'll look at, our list called A list, and we're going to try to find the first occurrence of, let's say, a 65. And we know that 65 occurs at 1, 2, 3, position 3 in there. We'll go ahead and print that out, and there's position 3. That's where it found the 65. Okay, if we tell it to find 655, that should not be found. Most languages then return a -1. This guy returns a 0. Okay, why is 0 okay in this? Most languages return a -1. Why is 0 okay for Blockly? Well, I could handle negative numbers. A little bit ago, I mentioned that most languages index things starting at 0. So if something had a length of 5, the legal positions would be 0 to 4. Blockly starts at a length of 1, which is actually fairly rare in modern languages. I wonder why they actually even made that decision. So it starts at an index of 1. So really, 0 is any legal index, correct? There isn't an index called 0. So 0 to something that starts at index 1 is the same thing as a -1 to something that starts in index 0. But we do have this new knowledge now that whenever we search for something in a list using the find first occurrence, it gives us a 0 if it was not found. That could be a handy piece of information we could use to solve certain problems. Okay? We could also find the last occurrence, so whether we're looking for something first in the list or last in the list, we can find it. We can determine whether a list is empty. So I'm going to print out our variable A list is empty, and this should be false. It's not empty. It's got a real stuff in it. So there's my false, not an empty list. Okay, so these are trues, falses, Boolean expressions, only return a value of true or false, right? We can get an element at a specific index. So I can say, go ahead and print out the value at index 2. And that should give me a 55. So this is our way of accessing a specific element. What row? Oh, I got to give it the name of my list. In list, A list, get bucket 2, which is a 55. All right. We can also get and remove something from our list. So this would print it and then get it. And if I repeated this whole line, the first time through, bucket 2 is 55. The next time through, bucket 2 would be 65 because I actually removed this guy. Okay, so we'll see that whittle it down, 55, 65. Okay, so we have the option to just get ourselves a copy of what's there, or get ourselves what's there and actually physically remove it from the list, or we could actually just remove something from the list. And notice when I said remove it from the list, it doesn't return a value. So some of you have been struggling with the difference in functions between functions that return a value and functions that don't. Well, here's an example of, we have a function called get and remove, which takes in a number as a parameter and ultimately removes the element at that position in the list. And it returns it. So notice that I have a puzzle piece to work with here, and I can plug it into something else and let it use the value that was returned. This guy, though, does not return a value. Visually, we know it doesn't because no puzzle piece. Okay, no puzzle connector over here. Okay, but all this guy says is, whatever's at position 2, get rid of it. Okay, get rid of whatever's at position 2. We can't connect this to anything. We can connect it here. So for instance, I can do this. I can build my list, immediately remove the element at position 2, and then print out the new position 2. So this would be 1, 2, 3, After remove this guy, position 2 is 65. Now, what that tells us is when we remove something, the list automatically resizes, which means that whatever this gap that's created here closes. When we remove this guy, this gap closes, and 55 or 65 becomes the new bucket 2. Okay? Let's see. We can get a portion of the list. Well, actually, here, let's look at set first. So again, in list, a list. Notice this guy does not return a value. We can set or insert at a particular place. So set's going to overwrite what's there. So for instance, I'm going to set position number. So notice that we have a couple different ways of indexing. We can just give it a number. We can give it a number relative to the end of the list. We can give it the first, last, or I don't know why this would necessarily be all that handy, but it's there. We can just randomly change some value in our list. Fair enough. But in this case, I'll just set one of the values. And we're going to change whatever we've been working with bucket 2 here. So we'll go ahead and change whatever's at bucket 2. To 131. So we'll build our list here. Bucket 2 is a 55. We immediately change bucket 2 to be 131. And then we can just do get here instead of removing it. We'll have the same output for us. So now it'll print out a 131 rather than the 55 that was there before. So we're actually modifying it. And we can see that if we go and we do a print. We print out a list. And we'll see that our list, there's the 131, our list now has had bucket 2 replaced with 131. Okay? That's different than us saying insert at position 2, a 131. That's just going to push everything out. So what used to be at position 2 will now become position 3 and so on, and we have a new element that's been added to the list at position 2. So there's my 131, and here's my list where the 55 is still there because the 131 just displaced it. All right, so we have a whole bunch of ways. Oh, here, finally a sublist. So from this guy, we're going to say, give me the sublist from position 1. Actually, yeah, well, that'll work. From position 1 to position 3. All right, from 1 to 3. So this is going to get us everything from 1, 2, and I suspect position 3. It seems like this the MO so far for Blackley is the second number is inclusive. So I think this should give us the sublist that is the list containing 33, 55, and 65. It might give us just 33 and 55, but I think it'll give us 65 as well. Yep, there's our 65. So it is inclusive like everything else. So it gave us the entire list except for the very last element. Make sense? Okay, now let's say, now that we kind of know how lists work, what if we wanted to have a function that took a list in as a parameter and it returned a new list, which was the original list in reverse? So pretty similar to what we did for homework, but now we're working with lists instead of strings. Okay, and I think what we're going to find is actually lists are implemented in Blockly using the same logic as strings are. So we'll do our same function. So we'll call this guy reverse list. And this guy's going to take an input as a parameter, and we'll take in something called LST for our list. All right, again, we need a loop that's going to go through all the elements of the list and print it backwards. So again, we'll start off small steps. So we're going to count. Actually, I think we have another loop we can introduce here. Yeah, we have a for loop that walks a list. So let's look at this guy. So here's a for loop. So for each item I in list LST, do something. And for right now, we're just going to print it out. So we can see how this guy works. So we'll print out I. So each time through this loop, I will be equal to the next element in LST. Okay? And in the actually, we won't even return anything right now. Just leave it like this just to see it. And we'll go ahead and call upon our function, reverse list with, and I'm going to go into our lists, and we'll go ahead and do this version, make list from text, and the text we give it will be something along these lines. One, two, three. Okay, so 1, 2, 3 separated by commas. We tell it it's separated by commas. It'll create a list from that. We'll pass that list into our reverse list. Reverse list, we'll use this for each loop to go through every element of LST, storing each time through storing the current element in I, and then we'll print out I. So this should print out a 1, then a 2, then a 3. There's my 1, there's my 2, there's my 3. All right, but I want to walk through this guy backwards. A for each loop isn't a tool for doing that. A for each loop is one of our repetition tools. It's a loop, but it allows us to go through every element in a list without us having to physically put in the positions. We don't have to say, go from bucket 1 to bucket count. Access the element at bucket 1, the element at bucket 2, the element at bucket 3, the element at bucket I. We don't have to say that each time. Instead, this guy does most of that work for us and just gives us each element stored in a variable at I. Okay, so this isn't the right tool for the job for doing something in reverse, but it's certainly a nice convenient way of going through every element in the list. Okay, now, one downside to this, though, is if you need to know where in the list you are, this guy's not going to give you that index. It's not going to tell you where in the list you are. If you need to keep track of that and you still wanted to use a for each loop, you would maybe have to go and create a variable. Maybe you call this variable curpos or something like that. And we're going to start this guy off at 1. Because when we first fly through our list, we'll be at position 1. So maybe we print out the element there, and then we also print out the current value of curpos. And then we set curpos equal to whatever currently is plus 1. Let me see if I had a plus plus. Okay, so now I've had to modify a for each loop because it didn't give me my index. It didn't tell me where in the list I was. It just guaranteed that I would be equal to each element of the list in order. But now I'm interested in where we are, so I had to keep track of this extra variable called curpos to remember where we are in the list and add and subtract or do the addition myself. Okay, so when I run this now, we'll set curpos to 1, go through every element in our list. We'll print out the element in our list, which will be 1. Then I'll print out 1 for curpos. Actually, let's change this to 14, 15, 16, just so they're not matching. So this will print out 14 at position 1, 1 becomes 2. 15 at position 2, 2 becomes 3. 16 at position 3, 3 becomes 4. Then the loop ends. Okay? And we know that curpause did indeed become 4 because what we can do is we can steal this line and print it after the loop. So curpause did go from 3 to 4, and then we ran out of elements in our list. Now when we fall out of that loop, we're going to print out curpause, and its final value will be 4 because we did update it one more time in our list, or in our loop. There's 14 at position 1, 15 at position 2, 16 at position 3, and then there's our 4. All right, makes sense? All right, what if I wanted to store all of the powers of 3? Well, actually, let's do this differently. What if I wanted to store all the numbers between 1 and 100 that were evenly divisible by 3 into a list? So I need a storage container, right? So my list is where I'm going to throw these numbers. I'm going to throw a 3 in there. I'm going to throw a 6 in there. I'm going to throw a 9 in there. I'm going to throw a 12 in there. All the numbers between 1 and 100 that are evenly divisible by 3, I want to throw into this list, this container, for holding similar kinds of values under a single variable name. All right? So let's just change the name of this guy. We'll call this guy, oh, we never actually reversed our list. Let's finish reversing our list. Somebody remind me about what we were just doing next time. Here, I'll write a quick little thing here. Store powers, store numbers divisible by 3 in a list. Good enough there. All right, so again, we don't need to know about curpause. We don't need any of this stuff really, and actually the list isn't really good for us, or that loop isn't really good for us. We need to use our other loop that allows us to deal with count, since we need to access specific places in our list. So we're going to count I. We're going to start it off at the length of LST, so the length of the list that was passed in, going to 1, counting by -1 each time. What am I going to do in there? Well, I want to reverse the list. Well, I'm probably going to have to build a brand new list. So I'm going to set a variable. Let's call this guy new list. And he's going to start off as the empty list. And each time through, I'm going to append a value onto my empty list. What am I going to append? I'm going to say set new list at position I, and I know we're basically out of time, equal to my old list just LST get position I. So each time through, we'll set bucket 0 equal to, I'm sorry, actually, no, this isn't going to be bucket 0. This will duplicate the list. We need this guy to count from 0, 1, 2, 3, 4. We need the other list to count from 4, 3, 2, 1, 0. So we really need 2 counters, okay, to keep track of where I'm adding stuff in here. All right, so we'll finish this up next time. No homework assignment over the weekend since we have some hackathon guys gone, so they don't get homework, so you don't get homework either. See you back here on Monday, probably exhausted, but have a good one. Have a good weekend.